Amazon, Apple, Microsoft, and Google, all those companies are asking this question recently. You must know how to solve this question. This is Leetcode, climbing stairs. We're given n steps to reach the top, and every time we can only climb 1 or 2 steps. We need to return how many distinct ways so that we can climb to the top. If n is equal to 2, we can either take 1 step at a time or 2 steps at one time. So this will give us 2 ways. There are multiple ways to solve this question. One is the brute force. Basically, we get all the combinations of the ways, but this is going to take 2 to the power of n. Next, I'm going to talk about recursion and dynamic programming, which is going to take O(n) time. Climbing the stair is equal to going down from the top. If we have n is equal to 3, we have 2 options to going down. Take 1 step or 2 at one time. So eventually we'll reach out to the bottom, and we have 3 different ways. In recursion, we need to return the result. So if we hit 0, then we need to return 1. And this is 1, and this is 1. If we hit -1 or less than 0, we need to return 0 because this is an invalid path. So eventually we have the sum of 3, 1. So we get the output which is 3. Now there are something we can improve with the memorization. You can see this one and this one here. They are repeated calculation. So we can actually cache the result into memory so that we can save the complexity time. At this point, I have a question for you. Do you know why the recursion is taking O(n) time? You can leave the answer in the comments. And this is the Python code. First, we declare a variable to cache the result. If n is equal to 0, that means we have a valid path like this, this, and this. If it is less than 0, like -1 and -1 here, that means this is not a valid path. So eventually, we have the base case to return the value, and then we return the temp n. Alternatively, you can use LRU cache Python library. You can boost up your time complexity to beat 96% of the user. Next, I'm going to talk about dynamic programming. Let's denote I as n, and we can put everything in an array. You can find the pattern here that at index I, it's actually equal to the result of I minus 1 plus I minus 2. And this is actually Fibonacci sequence. This is the Python code. First, we declare an array with all the 0 inside. And then we initialize the first and the second element to 1 and 2. Finally, we implement this equation. The space complexity is O(n) because we declare an array with n size. If you like this channel, please click like and subscribe. Thank you.